Climate is included here with three other factors that influence the distribution of vegetation across the landscape. As mentioned earlier, climatic factors include the relative amount of solar radiation and precipitation an area receives. Geologic factors include the type and productivity of soil present as influenced by parent material, and the above climatic factors. Natural disturbance regime, an ecological factor, refers to the type, frequency, and extent of natural disturbance throughout an area. For example, in the southern Appalachians, wind throw and blowdown events that create canopy holes less than a half acre in size are really common, whereas stand replacing fires are not, or large landscape scale fires are not. In the boreal forest of Canada, those sort of stand replacing or large scale fires which cause canopy tree mortality across perhaps hundreds or thousands of acres, that's a relatively common event by comparison. Anthropogenic factors or human-caused ecological change is apparent in ecosystems the world over. Now, more specifically, solar radiation affects surface temperature and moisture availability, and as a result affects soil fertility and soil productivity as well. Areas along the equator receive more direct solar radiation. Areas at higher latitudes receive less. A greater amount of solar radiation results in warmer surface temperatures and greater rates of soil organic matter decomposition. Decomposed soil organic matter provides the primary source of nutrients like nitrogen and phosphorus utilized by trees. Surface temperature is also influenced by a phenomenon referred to as thermal buffering, which we'll look at here in a moment. Thermal buffering results in a modified climate for land areas directly adjacent to large bodies of water. This occurs because land and water lose and gain heat at different rates. As an example, Portland, Maine is at roughly the same latitude as Madison, Wisconsin, but the winters in Portland are warmer while the summers are generally cooler. This is a result of Portland being situated adjacent to the Atlantic. Here's just a postcard shot of Portland, Maine, looking inland with the White Mountains way off in the distance, just so you can get sort of a feel for how it's situated along the water there. Tree growth is also influenced by soil moisture, which is typically the most limited site-based resource trees utilize to grow. Higher surface temperatures result in less available soil moisture because evaporation and evapotranspiration rates are higher. In addition, more precipitation can result in an increase in soil moisture as well. Globally, tropical rainforests are located adjacent to the equator where air patterns result in heavy, consistent rainfall. Further away from the equator along the Tropic of Cancer and the Tropic of Capricorn, we find the world's large deserts, where there's not enough moisture to support tree growth. The next slide illustrates this phenomenon. This cartoonish slide here illustrates the points from the previous slide. Our atmosphere is fluid, and hot air consistently rises, right? As air absorbs heat, molecules move and expand, making the heated air mass less dense than the surrounding air, causing it to rise. Along the equator, the relative amount of solar radiation results in a significant concentration of warm air, which rises rapidly. As the air rises, cools, and condenses, precipitation occurs. It's here where we have our rainforests. As the cool air moves away from the equator and begins to sink, you get areas where there is little atmospheric moisture, and these are where our deserts, our large deserts, are generally located. This slide here just provides an illustration of rainforest distribution throughout the world. Precipitation levels are also influenced by an area's proximity to a large body of water, like the oceans or Great Lakes, as well as by the topography of the area or the shape of the land. coastal areas generally receive a greater amount of precipitation than inland areas because the moisture-laden air incoming from the ocean rises over land due to the temperature gradient and drops precipitation as it moves inland. The same dynamics influence precipitation amounts in mountainous terrain like western North Carolina. As air is forced up on the windward side of a mountain range, the precipitation falls out before the air mass cools and moves down the leeward side. This is why parts of Jackson County in western North Carolina may receive 70 inches of rain in a year, while portions of Buncombe County on the leeward side of the range may only receive 35 inches of rain during the year. This is an illustration of what's referred to as orographic lifting, the phenomenon where air is forced up a mountain on one side, on the windward side, leaving that side wet as the precipitation falls out and the leeward side dry. Soil fertility, or the ability of soil to provide for the nutrient and moisture needs of vegetation, has a large impact on whether or not trees can be supported, and if so, which species of trees have the ability to persist. Soil consists of both decomposed organic matter and broken down mineral material. The chemical composition of the mineral material, the mineral component, is determined largely by the bedrock or parent material from which that soil was formed. Soil texture, or the relative size of soil particles, influence fertility as well. Sandy soils with relatively large particles often drain rapidly and contain less available moisture. Soils with smaller particles like silt and clay have a higher nutrient holding capacity because there is more particle surface area per unit of soil. Generally, our most productive soils, as we'll talk about later in the semester, contain a mix of all three particle sizes, referred to as a loam. The amount of precipitation is also a key factor regarding soil moisture availability, but there are many areas where precipitation rates are high, but the soil is sandy, resulting in little available moisture for plants. In locations that have been subjected to heavy precipitation over long periods of time, like tropical rainforests, nutrients are leached from the upper layers of the soil, as we discussed earlier. That process of leaching is where water molecules with soil nutrients attached move through the soil profile, making those nutrients less available for plants to utilize.